Okay, this is our review for the week of November 4th through 11th. I'm just going to go ahead and work through all of the problems, and then you guys can, it's just meant to help you check your work as you go. So, if you don't have to watch the whole video, obviously, just watch the ones you need help with. So, these are definite integrals. This is where you're actually going to be plugging numbers in. So you're going to integrate first. That's our first step. After that, we're going to plug in. And subtract. One where we plug in the 1. And one where we plug in the -1. So we're going to go ahead and simplify here. So this is going to be 1/3 minus 1/2 minus 1. Here, -1 to the 3rd power is -1, so that's going to be -1/3. -1 squared is a +1, so it's going to be minus a +1/2. And then double negatives here is a positive. We also want to make sure we distribute our negative here. So when you do that, this becomes a positive, positive, and negative. And then we just combine our like terms. We have a 1/3 and a 1/3 makes 2/3. We have a -1/2 and a +1/2 cancel each other out. And a -1 and a -1 makes a -2. And we're going to need a common denominator here to get these together. So 2/3 minus, so if I put this over 3, the top becomes 6. Yet -4/3 would be our final answer on that one. Okay, so that is number 1. Let's move on to number 2. I'm recording a lesson, which you'll hopefully watch this weekend, but I'll see you later. Okay, let's go ahead and do number 2. All right, cover some stuff up there. All right, number 2. All right, how are we going to do this one? So what I'm noticing here is I might want to start by splitting this up into 3x over 3x minus 1 over 3x, which means it's going to become 1 minus 1 over 3x. And then I'm going to integrate these two things separately. I'm not writing my dx's, naughty boy. All right, anyway, there we go. So integrating this should be relatively easy. The integral of 1 is just x. Integrating this, on the other hand, we might want to review a little bit. I'm going to show my work over here, but then I'm going to write my final answer right next to it. So first of all, I'm going to let u be equal to 3x, right? So if I let u equal 3x, that means du dx is equal to 3. And if du dx is equal to 3, then du over 3 is equal to dx. So I'm going to replace 3x with u, and I'm going to replace dx with du over 3. And what I'm left with then is 1/3 integral of 1 over u du. And hopefully you guys remember that's a log. So what we have then is ln of the absolute value of u. And our u in this case is 3x. Okay, and so that's what we have here. So it's 1/3 ln absolute value 3x. And once again, we're going from 1 to 2. Okay? Okay, so the first one's easy enough. We're going to plug in 2 and 1, right? That's for this guy. Then we have the same thing over here. We're going to plug in 2. So if I plug in 2, I get 6. And then if I plug in 1, I get, it's supposed to be a 3. 3. Okay? Okay, the one in the front here is just going to be 1, right? 2 minus 1 is 1. Minus. Now in here, what I'm going to do is I'm going to pull some fancy moves, because when I look up here at my answer choices, they all have just one log, right? And there's a way I can get these 2 logs to become 1 if I use my properties of logarithms. First of all, I'm going to pull out that 1/3. I don't like that 1/3 sitting there, so I'm going to factor it out, and I have this, right? Just divide out that 1/3. Now there is a property of logs, and the property of logs that I can apply here states that whenever you have 2 logs being subtracted, you just divide their argument. So 6 divided by 3 would give you 2. And then we don't really need those brackets anymore, and we can see that the answer we want to choose would be, this guy right here, it looks like. So don't forget those log properties for the multiple choice questions. They seem to want us to use those every so often, so they're good to know. All right, let's move on to number 3. Okay. So in this case, we're going to integrate first, and we're going to want to do some U-substitution. We're going to want to let the U be equal to 4 minus t, and then the derivative of u with respect to t is -1, which means that du is equal to a negative dt, or in other words, negative du is equal to dt. Because remember, we want to get dt by itself, so after I multiply both sides by dt, I get negative dt, then I divide both sides by -1, and I get negative du. So now we rewrite this, and something I guess we can do here, I didn't do it last time, and you don't have to, but I'm going to do it this time. First of all, we have a negative du is going to take the place of the dt. Now I'm going to put that in parentheses so it doesn't look like minus du, because it's not. It's -1 du. Also, I'm going to replace the inside there with a u. And we also can go ahead and replace these limits. Remember that when you change your variables, you're also going to want to change your limits. So if t equals 3, then what would u equal? U would equal 1. So when t equals 3, u equals 1. And then also when t equals 0, u would equal 4. So when t equals 0, u equals 4. So there's our substitution. That -1 there, we're going to go ahead and factor that out, first of all. Right? Second of all, this square root is a half power. Third of all, I don't like terms in the bottom like that, so we're going to change it to a negative half power. And now we're ready to go ahead and do our math. So we have the integral of u to the negative half. So if I add 1 to a negative half, I get a positive half. And then we divide by that number. But dividing by a half is the same thing as multiplying by 2. Remember how you multiply by the reciprocal? Then we just plug in our numbers. So we have 2 times 1 to the half minus 2 times 4 to the half. And you want to remember what a half power is. Remember, that's a square root, which means you have 2 times 1 and 2 times 2. Final answer, -2. Let's move on to number what? Number 4. All right. So I think we're going to be doing some more U-substitution here. But this time, gosh, they're already using a U. That's kind of confusing. So why don't we do a different letter instead of U substitution? This time let's do P substitution. So I'm going to let this whole thing in here equal P, right? Then we're going to take the derivative of P with respect to U, and that's going to be 3, which means that du is dp over 3. Okay, so that's going to be the square root of P, and we've already stated that du then is going to be dp over 3, and we also need to change our limits. So when u is 0, what would P be? Plugging in 0 here, you would get 4. And when u is -1, so if I plug in a -1 instead, -3 plus 4 would be 1. So we've changed our limits, we've changed our d, and we've changed our p. So let's go ahead and do some more here. We're going to factor out that 3 on the bottom as a third. We're also going to change the square root and do a half power. And now we're ready to integrate. So if I were to integrate this, I'm going to add 1 to the fraction there. So that's going to become p to the 3/2. And then we're going to multiply that by the reciprocal. Don't forget, we have a 1/3 in the front still though, right? We don't want to forget about that. So, first of all, I'm going to do 1 times 2, which is 2, and 3 times 3, which is 9. And then we're going to go ahead and plug in for P, right? We're going to plug in 4, and we're going to plug in 1. Now let's not forget how to do this. You can't use calculators on this. You're supposed to know how to do this mentally. So first of all, 4 to the 3/2 power. What that means is, I'll show my work here on the side, is that means we're taking a square root, because it's a denominator of a 2, and we're raising that to the 3rd power. So what's the square root of 4? It's 2, and then we have our 3rd power, so 2 to the 3rd power is 8. So we end up with 2 over 9, parentheses 8. Now this one's easy, because 1 to any power is always 1. So this one's kind of negligible. 2/9 times 1 is just going to be 2/9. So let's go ahead and figure this out now. We have 16/9 in the front, minus 2/9, which is 14/9. And there she is. Okay, moving along. Let's do number 5. Okay, let's do some U substitution. We saw this earlier today. I didn't really make a big deal of it, but I will now. We don't usually like that dy on the top, right? It makes more sense to us to write it on the side, so don't forget about that. All right, so in this case, my u would be 2y minus 3. The derivative of u with respect to y would be 2. And therefore, du over 2 would be equal to dy. So, 1 over u, du over 2. Don't forget to change your limits. So when y is 3, if I plug in 3 for y, 2 times 3 is 6, take away 3 is 3. And if we plug in 2 for y, 2 times 2 is 4, take away 3 is 1. So my limits go from 3 to 2 to 3 to 1. Of course, we want to take out that half, right? And the integral of 1 over u, whenever your power on the bottom is a 1, that's when you do the ln rule. So the integral of 1 over u is ln of u, absolute value, I should say. And so we end up with 1/2 ln of 3 minus 1/2 ln of 1. Now, ln of 1, there's a property for that. Ln of 1 is 0. I can explain why in a second if you like, but for now, just take my word for it. Half times 0 is just 0, so I'm left with this, and this is my final answer. Let's see if that's up there. It's not. So they want us to apply some more log properties. When you have a half in the front, that could become an exponent, right? And what's 3 to the half power? That's the same thing as the square root of 3. And there it is. So you got to know those log properties. Now, if you were wondering, why is ln of 1 equal to 0? I can kind of demonstrate it for you here. You don't have to watch this if you don't want to, but we don't know what this is. But I do know that ln is log with a base of e. I also know that logs are the inverses of exponential functions. So I can rewrite this as an exponential function with a base of e if I switch the input and the output. The input becomes the question mark, and the 1 becomes the output. And so the question is, e raised to what power equals 1? Well, the only way you can raise something to a power and get 1 is if that power is 0. So that means my question mark is 0. Okay. Let's go ahead and move on to question number 6. All right. Notice how the power on the bottom is 1 more than the power on the top. That's another great opportunity for some U-substitution. Okay, so we have the integral of x over square root of u du over negative 2x. So first of all, the x's cancel out, and the negative half can come out as well. And we also need to change our limits. So square root of 3. If you plug in the square root of 3 here, well, when you square the square root of 3, you get 3, and 4 take away 3 is 1. Plug in 0. 4 take away 0 would be 4. So let's rewrite it some more. This is a half power, and it's in the bottom, so it's a negative half power. And now we're ready to integrate. So this is a basic power rule issue. So we add 1 to the power, multiply by the reciprocal. Don't forget your negative half in the front. So this 2 cancels out that 2. So basically what we're left with is this. And then we go ahead and plug them in. So, we subtract them, right? But this negative is here, so you get double negatives. So 1 to any power is just 1, so that's negative 1 there. In this case, we're going to take the half power of 4, which is 2, right? Remember, half is a square root. So the square root of 4 is 2. It's a negative 2. Double negative makes it a positive 2, and the answer would be 1. There you go. All right, moving along, let's take a look at number 7. And there it is. Okay, another U-sub problem. U-sub is pretty important, as you can see. Let's change our limits. If I plug in 1, I get 1. If I plug in 0, I get negative 1. Oh, and this is supposed to be cubed. Sorry about that. All right, let's take out our half. Let's integrate. So we're going to add 1 to the power, divide by that, and we end up with u to the 4th over 8. We multiply the fractions together there and plug in your numbers. So if I plug in 1, I'm going to get 1 to the 4th power over 8 minus negative 1 to the 4th power over 8. Now, 1 to the 4th power is the same thing as negative 1 to the 4th power because the even power cancels out the negatives. So since these two fractions actually end up being exactly the same, answer is 0. So option D. All right, let's take a look at number 8. So when you see a binomial or trinomial in the top, chances are that's like we did on, I think it was like the second problem. Chances are you're going to split the numerator up, right? So the first thing I would do is I would probably do 2 over 2 square root of x, and then I would do x over 2 square root of x. Treat those as two separate problems there. Should have a dx there as well. Now in this case, these cancel, right? Now square root's a half power, and since it's in the denominator, it's going to be a negative half power. This one over here we have x over 2x to the half. Now, this one's a little bit tricky. First of all, we're going to take this 2 out as a half in the front, right, on the bottom. Now, what is x divided by x to the half? Well, you just subtract your powers in that case. So 1 take away a half is a half. So you have a positive half now. And now you just integrate each piece as you normally would. So integrate this, you're going to add 1, so you get x to the half, and then you multiply by the reciprocal. We have our half, add 1 to the power, you get x to the 3 halves, multiply by the reciprocal. Now this one in the front here simplifies, the 2's go away. We multiply 1/2 by 2/3. So now we have the following. Oh, I forgot my power here. This was a half, I believe. Okay, so let's plug and chug. Plug in your 9. Plug in your 4. Plug in your 9. Plug in your 4. Okay, so this is the square root of 9, which is 3, and 3 times 2 is 6. Square root of 4 is 2. 2 times 2 is 4. That's easy enough. And then this is going to be 2 plus. Let's do this one. So we've talked about this earlier in this lesson. You're going to find 9 to the 3 halves power. And what that means is the square root of 9, that's the 2, it's its square root, and the 3 is a third power. So the square root of 9 is 3, and 3 to the third is 27. So this is 27. And 27 times a third is basically dividing 27 by 3, which is 9 minus, let's continue. Here, we're going to find the square root of 4 and then cube it. Square root of 4 is 2, 2 cubed is 8, so we're left with 8/3. And now we have 9 minus 8/3. So now let's combine the 2 and the 9 there. We get 11. And then we're going to need a common denominator after that. Notice I didn't do any U-substitution this time. That's unique, right? All right, so we have 11 minus 8/3. We're going to need a common denominator, so the 11 becomes 33 over 3. Subtraction, what would that give me? 25? There it is. That was number 8. Let's check out number 9. Okay, so first of all, we don't like that dx there. Doesn't really matter. I mean, you are used to it being there. It's not a big deal, but that looks a little more familiar. Now, first thing is that this is not going to be a u-sub, because if you do a u-sub, if you make this u, your derivative is going to be 2x, and the x isn't going to cancel everything on the top. Remember, u-sub only really works well whenever your denominator's power is 1 less than your numerator's power, and that way the x is canceled out. So this is not a u-sub problem. This is that pesky thing you just got to remember and got to recognize. It's an arctangent problem. Okay? So, the arctangent rule looks like this. So basically, we need to find out what x and a are and just plug them in the formula. X comes from taking the square root of this. A comes from taking the square root of that. So in this case, my a is the square root of 9, which is 3. And obviously, my x is just going to be x. So we have 1 over 3 arctangent of x over 3. And we are doing from negative 3 to 3. All right, so let's plug them in. So if I plug in 3, I get 1, right? So it's going to be 1/3 arctangent of 1 minus, now we'll plug in negative 3. That's going to be 1/3 arctangent of negative 1. All right, so now on our unit circle, I know that arctangent is restricted to this half of the circle. I know that arctangent equals 1, so I know that arctangent is 1 whenever tangent of some angle equals 1. Now tangent equals 1 at the middle of each of these quadrants, here and here. So in this case, that's pi over 4, and in this case, it's negative pi over 4. So for the positive one, we have pi over 4. And for the negative one, we have negative pi over 4. Now these double negatives cancel, right? And so you end up with a plus. So what you end up with here is pi over 12 in the front, because 3 times 4 is 12, plus double negatives, right? Pi over 12, which becomes 2 pi over 12, which is reduces to 6. Pi over 6 is our final answer there. That was number 9. Answer is C. Let's go ahead and take a look at number 10. Final question of the integral review. Okay. So we know that the integral of e to the x is just e to the x. But unfortunately, this is a negative x. Now, long way to do this is U-substitution. I'm going to do that first, but then I'll show you guys the shortcut to this, basically. But here we go. So I'm going to say u is equal to negative x. Du dx is equal to negative 1, which means that du equals negative dx. And getting dx by itself means that dx is negative to u. So we have e to the u, negative du. I'm going to put that in parentheses so it doesn't look like minus du, because it's not. And then I'm going to plug some numbers in here. So my limit was 1 when x was 1, but if I plug in 1, that means that u is negative 1. And if I plug in 0, I get 0. Take out the negative, and voila, we've got a nice simple e to the u du, which we know now the negative's coming down, and the integral of e to the u is e to the u, and we're going from 0 to negative 1. Okay. So plugging in -1, we get that. Plugging in 0, we get that. Now, first of all, anything to the 0 power is 1. And since this is e to the -1, I can write that as 1 over e to the 1. So now I've got 1 over e, -1 over e, minus 1. And do I see that answer here anywhere? I do not quite see that, unfortunately. You know, I forgot my double negative. Oops, let's back up a little bit. So remember when I plugged in -1 here? Got that. Then it's minus, then you plug in 0. But it's minus, and then that negative's there also. So it's actually supposed to be a double negative. That's a plus. So darn it, my 1 was supposed to be positive. Now I do see my answer. It's right here. In this case, my 1 is positive, and my 1 over e is negative, and that's the same thing. They got it in a different order, same answer. Now just so you guys know, though, I'll give you a shortcut in the future, I mean, if you're interested. Anytime you have the integral of e to the x, and there's something other than just an x, just a number, like let's say it's 3 or 2. In this case, I'll just say it's c. The integral of that is always going to be 1 over c e to the cx, just so you know. So like, for instance, when we had this, the answer is going to be 1 over -1 e to the -x, which is just that. Or if I gave you guys this, then that's going to be 1 over 3 e to the 3x. So, little shortcut. Only works, though, if this is a constant number here, x to the first power, then you can do it, okay? Well, that's it for your integral review. Helpful hint video. Hope it was helpful.